Picking up from last video, we just got our delta head and our two nodes are from nodes. And we use this to calculate them, but that's not the numbers we want. But since we have delta head, we can actually get our flows from which one? This. Define flow. So instead of printing now, we can do print flow delta head L I K I D I N E D I. Don't know if it's right. Let's see. I think I gotta add in pipes to all of them if I'm not wrong. Actually, no, I gotta add. Is it L? This needs to be D pipes. E pipes. Still don't know because I don't know what I'm K and L. Yeah, I need to put the K values. Ooh, whoa. K values here. It has to be the same, I'm pretty sure, from the pipes, right? And the L values. And yeah. So we got two negatives. Well, they're all negative. I realized somewhere I forgot something earlier. We need to find the difference between internal and external nodes. So let's do n number of nodes is equal to, now we're going to do np max pipes zero that as type int 32 plus 1 invalid. I'm going to need full parentheses around this. So I'm pretty sure I fixed it here. Sure. Yep. Let's do it in nodes. Okay. I think I found the problem. This should be delta H to head. And yeah, that gets weird. And now, if I put in 10, it's not working. Working again because of the flow function. If the number is really close to 0, it's going to give us this. And we need to adjust it that if it's really close to 0, we can just say the number is going to be, it's 0. So let's go. So delta flow, so right here. So if delta ABS is less than, so 1 to the 10th, return 0.0. To make sure I don't miss the colon that time. Segmentation plot. And yeah, now it puts a 0 in there. So that if it's that. So that fixes that problem. Now we need a function that calculates the net flows. So define C net Q. And what we're going to need in there is the flows. So I think I actually misplaced this. Actually keep that there and you put this here. But In pipes, yeah, I believe that's right. Actually, it's in pipes. It's in nodes, since we're trying to find the internal nodes on flow rates. And it's not flow, we're going to try to find the net Q. And what we want to return is the net Q value. So then we do the same thing that we did up here. This time it's going to be heads. Yeah. So now we're going to have C net Q with this inside of it. Let's see what we get. This is C net. Can run it. And it doesn't look right. Excuse me, the same values as I got before. I didn't return anything here. So flows. Yeah, it gave me the same thing. I'm not supposed to print. I need to call this as a function. So flows I is equal to shift enter, and now it calls that as an array. To change the zeros, we're gonna have to separate the internal and external nodes. There's a function called np add. We're gonna use the net Q, the two nodes, and the flow. And we have to do the same thing for the external nodes. So np add net Q. Instead, it's going to be from nodes, like I said, and it's going to be negative flow since it's flowing out. So we run it, and it gives us the array that we want. But we're going to do more because these are still kind of like guesses for set. And we still have three equations for three unknowns, which are the internal node. So we're going to define net internal Q flows. It won't be Q because we need actually the internal pressure. So it's an internal P, and what we're going to return is going to be return this. So return wrong. Except with the internal nodes, which we're going to have to define up there eventually. First, how are we going to get the internal nodes from this? Well, the internal nodes, so internal nodes, will be equal to the set range of n nodes minus the external nodes. External nodes. But I need it says set, so I'm probably going to need a list to actually do this function correctly. So let's say list. This is all encompassed. And set. I forgot that the set with the external nodes here. Let's see if it works. Let's go down. Shift enter. So turn 1, 2, 3. Yep, those are the internal nodes that we have. 0 and 4 are not included. So we continue this. Let's go back up. We should already actually have the head functions for at least the external nodes. So we do heads equals np zeros external nodes. I got ahead of myself. This should be end nodes. The next line is going to be so. And then heads. See, then now we do external nodes. It's going to be equal to. It's going to be equal to the pressures. So we're going to have the z. So the heights of the external or positions. External nodes external pressures. So external pressures. It says external nodes not defined. I probably have a underscore there. And there we go. You know that. So you do heads. So here. So heads. Okay. Of internal nodes is going to be equal to internal nodes divided by rho divided by G plus pressures, so internal P. Or actually, no, not pressure position, so Z of internal nodes. Okay. Now, since we have this, we just need an initial guess for the original internal pressures. So do internal. What should I name this? Internal head guess equal to P, that mean, of external nodes. So external underscore function. So I need, actually just add some parentheses here so it actually works. I'm also going to need an internal, what I need actually is an internal P guess. So this is going to be equal to, going to be the internal head guess minus the pressures, so Z, so that of internal nodes times rho times G. And now we can use the root solver, so root of net internal Q and internal P guess. I don't want root defined up here. Shift everything. And realized two errors. One is I had internal nodes here instead of internal P, and the other was I didn't have MP array on external pressures. So after I do that, this is what I get. So yeah, and then to get the final values, let's see where I have it. C net flows heads. This is going to get you the actual values of the 6 pipes. Shift enter. Well, actually, that's the actual flows of the 6 pipes. I want this on the next line. I don't want flows heads. I just want C flow. Yes, this one. This is going to give me the flows of the 6 pipes, and this is going to give me. So that's the flows of the 6 pipes, and the next line is giving me the net flows of the 6 of all the pipes. C source 0 is negative because that's the main source, so it's going to be negative in source that's flowing into all the other pipes. And this is how you code to get the net flows and the flows of each pipes.